And hello, ladies and gentlemen, and welcome to PASCO Laboratories. A very exciting day today. I'm JP, and this week the P actually stands for playoffs. That's right, it's the playoffs. It's football season, but it's not football here at PASCO Laboratories. It's actually spectroscopy. And we are going to be doing spectroscopy right here. And with me, we have Barbara and our sports commentator, Roger. And we're going to be doing some great competition. Roger, what's lined up for today?
I'm telling you, the lineup today couldn't be better. It's big and it's out there for you to consider. We've got our indescribable, visible spectrometer here on this side, and we've got the indisputable ultraviolet visible spectrometer on this side. We're going to see which one of these can meet the needs of your classroom and the explorations that you want to do in your sciences.
Well, we're going to find out, aren't we? It's a pretty good battle between Barbara and myself, and you're going to be here to come and do some commentary. We're going to drop in our scoreboard because we're actually keeping points on this on our playoff. Barbara, are you ready for this competition?
I'm ready. Are you ready?
I am extremely ready. We hope you're ready. Follow along closely because there's going to be some really tight competition. And so, how many rounds do we have, Roger?
We're going to have 4 rounds.
Three rounds.
3 rounds, that's right.
We're going to have 3 rounds, and our first one is going to be taking a look at analyzing light. And so in 3 rounds, keep score at home, we're going to be taking a look at analyzing light. Remember, ladies and gentlemen, we're live. So if you've got questions, just write them in. We've got people standing by to answer them. We have folks right here to answer them, and we are playing live. So this is not, if you're going to get your bets in, get them in now, because this is happening right in front of you.
Although we don't encourage, this is all in the name of science. And, you know, that betting thing can just be kept on the...
Oh, of course, yeah.
Of course.
We're just betting cookies. Now, our first competition, Roger, is going to be analyzing light. And so the question we're going to ask of our 2 devices is it hydrogen or is it helium? Pretty good competition, isn't it? So I've got my emission device here. I happen to have a tube in. Probably can't see it glowing at home, but it is. And it is emitting one of those gases, hydrogen or helium. I'm not going to tell you which one. What I am going to do, though, I'm going to take my visible spectrometer, and I've got it hooked up with a fiber optic cable. I am going to hold this fiber optic cable right next to the light source here. Here we go. There we are. And I'm going to collect some data, and I believe I've got my data collected, and there we have it. Look at what I've got here, Roger. I've got a very nice spectrum of the emission of whatever that gas is. We're not seeing it.
That's right.
We've got a very nice spectrum there, and it's very nice in the software. We actually have built-in references. So the question was, is it hydrogen or is it helium? Let me drop in the reference for helium, or rather hydrogen. This is hydrogen. Which one is this? This is helium. Actually,
that's the helium.
So this is the helium. Is this helium?
I would say that's a miss for the sun there, because
Okay.
helium is a big spectra that was found in the sun.
Okay, well then, let's see. Let me drop in the spectrum for hydrogen.
Wow.
Oh, look at that. A beautiful alignment. So what's my guess? Is hydrogen. I would say my visible spectrometer did a great job with its fiber optic cable in determining that this was hydrogen, because I can see the peak. And so I'm pretty pleased with what my device just did here. Thank you. Thank you. Barbara, can you compete with that?
Yeah, that was okay. Yeah.
Oh,
Good job.
okay. All right. Okay.
Now-
Barbara's
Bring it on.
coming to swing.
Bring it on.
Let's
Okay.
see where it is.
Let's see
Absolutely.
what you've got. All right.
There we go.
Well, I'm trying the UV Vis spectrometer,
Okay.
and I'm going to do the same thing that JP did. I'm pointing at the source, and I'm going to collect my data.
Okay.
Should
Wow.
Oh,
That is one sharp spectrum.
Wow, that
telling you.
is an absolutely beautiful spectrum
Yep.
that we got from her UV Vis, and
Looks a lot like yours.
it does. It looks a
little
lot like
different.
mine, but of course there's more of a range there. Let me bring in those same references and see how her device did. Let's bring in the helium.
Oh, and this time is the hydrogen. We're right on in this. Oh, sorry, you're right.
Oh, no,
That's the
yeah,
other.
this is the helium.
Yep, okay.
Not a good fit, but
Yep.
let's bring in the references for hydrogen, and wham,
Tell
right
me.
on it.
It's
So this is really very
driven
good.
home, that's
So
right.
what's our score, Roger?
It's like a boxing match. We came out even on this round, 1-1. Both of these spectrometers are fantastic for looking at emission spectrometers.
Ah, that's terrific. Okay, so, but Roger, what would happen if there were things I wanted to look at that maybe I couldn't see in the visible? Barbara's have an edge up? Would this be an unfair competition?
I think we're going to find that it's a much unfair competition because outside of what you can see, the visible light, we're going to have a machine that's specially tuned to operate in those areas.
Okay, and we actually have an example of that, don't we?
We do.
Because we know that mercury is one of those great emissions that though we see something, because we see the color, there's things that we can't see that's happening in the UV. In fact, if you take a look here, I've dropped in the references for mercury, and we see that there are some peaks that we'd expect to see down in the UV.
Yeah.
So what do you think, Barbara? You ready to show me what your device can do with that?
I'm ready. Let's change that bulb out.
Let's change this bulb out.
I mean, we would still be able to see some of those peaks on the visible spectrometer, right? Because some of them are in the visible region.
True. Yeah. We still see the visible. But now we're going to see if we can see the ultraviolet. And so I'm going to turn that on. Beautiful light there for you, Barbara. Go ahead and drop in your fiber optic cable and collect your data.
Okay,
got it. Wow.
Look at that. I'm telling you, that is a fingerprint of what we should be seeing.
Well, let's find out. Let's bring in that actual fingerprint. Let's bring in the reference for mercury. Look at that, Roger. Wow. Down there in the UV, I can't see it. You can't see it. That device saw it. What's that tell us?
I'm telling you, you can look at things that are beyond what our normal visible spectra can, so that the whole world of organic chemistry, if you're out there doing things, or the microbiology world of DNA and RNA, we should be able to see where the excitation is either absorbing light in that region or emitting light in those regions. So we're excited about what this tool can do.
Wow, that's good. It looks to me like we're scoring another point for the UV Viz. Our score now is 1-2. Barbara is winning, but the competition's not over yet, is it?
That's right. Don't turn that channel because there's still an inning left.
All right, round 2. You ready, ladies and gentlemen? Round 2. What do we have for round 2, Roger?
Well, let's take a look and see what we can in these oils that we have that are out.
No, let's do some colored
Solutions first because that's the closer one. Let's start with these colored solutions and we see what we can do there.
Right, because what we know is oftentimes in our laboratories, what we're doing is taking solutions that we know and using them to determine something that we don't know. And of course, we're going to apply Beer's law for that. And so
nothing to be confused with tailgating or any of those things. But
no,
we find a
not in these playoffs. No, this Beer's law is totally about linear relationships, about what we know and what we don't know, and how we can calculate that. So let me do that. I'm going to bring in my solutions. These are what I know, and I'm going to put in my solutions, and I'm going to take a look at a peak that I want to analyze here at about 620 nanometers, it looks like. So that's what I'm going to analyze, at about 620 nanometers. Keep that in mind, Barbara, because you're going to be working with me and competing at that same level. So now that I know that this is where I'm going to be doing my analysis, I'm going to bring in my samples. I've got one sample. I've got a second sample that I'm recording.
Okay.
And I've got my third sample that I am recording. So 3 knowns. 3 samples. Look what I did, Roger. Wham!
Look at that.
A beautiful straight line that I was able to create. 3 points, a beautiful straight line. That's what I would expect, because I know this. It's a linear relationship. And now,
let's find out if we can find an unknown amount.
Yeah, don't know what this is, right? It's a secret.
That's right.
Okay, let's find
somewhere
out.
Between these others that you've measured.
I put that in there, I take a look, and here we are. I am able to determine it's at about 0.82. So that's a pretty good determination. So straight line, linear relationship, great determination. It looks to me like I've got this one in the bag, a solid winner in this case. I can't imagine that Barbara can compete with this.
Like a precision pass thrown right in between the defenders, that baby came right in there. We found the concentration. Let's see what we can do with the UV viz, Barbara.
I'm going to try to get at least as straight a line as you got. But first I need to get my analysis wavelength. Okay.
Wow, look at that. Okay, I'm already seeing that she's got some range on that. But still, we're at 620, so good. Okay, we're going to pick that.
Wavelength.
Perfect, good.
Okay, and now I can do my...
Sure, take a look at your 3 knowns. Yep.
Calibration curve. So I've got this one and my second.
Notice this is a little less colored, so it's less concentrated. And even the lightest.
Her third.
My least concentrated.
Collecting her data. Solution. And let's see what she's got. Let's bring it up. Oh.
It's a pretty straight line.
Yeah, pretty straight line. It's a perfect straight line.
That's right.
Again, showing a great relationship that we can do here. But Barbara, can you do the unknown?
course
you
you can.
able to determine the unknown based on this straight line?
I'm game. So here's my
Okay.
unknown. We're going to see if where it falls along there to determine its
Uh-huh,
concentration.
collect that, and bam, falls right on the line.
Yeah.
We're able to determine it's 0.85, a very similar number.
Absolutely.
It looks like a very good number to me. That's saying that we both scored
Yeah.
in
That's
this,
right.
right? I was able to do Beer's Law. She did Beer's Law. We had a straight line. We got that analysis. The score is 2 for me, 3 for you. Let's do an instant replay, Roger. When you look at these spectrums, what do you see?
I'm excited seeing both of these spectrometers can get into your classroom and really deliver what you want, and that is to see concentrations based on the darkness of the solution, whether it's lighter blues and darker blues or darker reds and lighter reds. But then you can put in an unknown amount, and both of these will determine what that concentration is going to be.
But what happens, Roger, if I can't see a colored solution? I bet there are some solutions that don't have a color that are just not going to work in the visible range. Is that true?
That's true. Most of the organic compounds that you're working with, or like think of table salt and some of those, they just go into solution and they look like clear water. And so now we need some range to look outside of the visible light and then get in there and determine what concentration of species there are dissolved in water or other liquids, solvents. And that's where we're going to have to depend on the UV vis.
I see. So here we're taking a look at aspirin, for example. If I were looking at aspirin, of course, I see a very nice peak in the UV range, but there's absolutely nothing in the visible. It's a clear
right.
solution as far as
Right.
I'm concerned. So my device will not pick up aspirin or any of those double bonds, some of those organic molecules, but her device will.
Aspirin,
Sounds to me like-
caffeine are big classic variables that I think you're going to want to use out there in those labs. And so let's see if we can't do those with a UV vis spectrometer.
And so the score now, 2 for me, 4 for Barbara. What do you think so far? What's
We're
it looking
pulling
at?
away a little bit because of that extra wavelength range. We're seeing that there's some functionality that you're going to be able to want to do with the UV vis.
Wow, okay, all right. We can bring this together, though. We are still one round away
round more.
from our finals. So here we go. Round 3.
All right, here it is. Let's bring it up. Line these
Okay.
babies going.
All right, chlorophyll analysis. Okay, this is a tough one. And I really don't think Barbara has a chance in this competition because this is a case where, I mean, you can look at it. You can see it at home. Chlorophyll has color. And color is going to show up very easily in my visible spectrometer. And so I'm going to put that in, and I'm going to see exactly what happens. We got a question coming in from at home. Go ahead.
Here's a question. Is it possible to get the responsivity spectra of the detectors for the vis and UV vis PASCO spectrometer and also the light source spectra?
Sure. Yeah, I think we have this published actually under the specifications on the website, don't we?
That's where you would find those materials. If you are looking for something in specific in terms of what's the, I mean, we have LED light sources in the visible spectrometer. That's visible spectrometer's got just a red, green, and blue supplement to a white LED, so that's what's shining here. In this case, we've gone to a hydrogen deuterium, actually a deuterium light source that gets us that broader range. Now, if you want the spectra, what we'd need to do, we don't have those spectra posted, but we do have those in the testing kinds of environments. That's something we can add.
Yeah,
Absolutely.
Maybe if he leaves his email.
Yeah, please, just
Sure,
leave the email. We can send those to you.
Absolutely. And so great question back there. Glad you're following the competition. We continue with our competition now. And so remember, we're looking at chlorophyll now. I think I'm going to be the ultimate winner. I'm going to put that into, let me start with canola oil because I think that's a good place to start. Any chlorophyll in here?
Shouldn't be anything
Right.
that we can see.
Right.
Certainly.
So I'm going to put that in there. I'm looking for a very specific peak for chlorophyll. Don't tell Barbara because it's a secret. Let me drop that in here. And what do we see?
That's exactly what you see, too.
Yeah, nothing.
Yeah.
Really don't see anything. There is no peak. I'm looking right around that, in that 600 range. I should be seeing a peak for chlorophyll. That's what we're always looking for. So let me take this out, my canola oil. Let me put in the olive oil, which I do know does have chlorophyll in it. Let me capture that spectrum, and wham!
There it is.
Look at that.
Plants need a little red light. They need a little of the purplish and bluish light so that they can complete the process of fixing carbon from the air into its starchy sort of substances.
And so now I'm able to see that. I see that peak. I see that. Let me bring those two peaks together. I see that beautiful peak. It's at about 660, so I see that as chlorophyll. It's a nice peak right there. I see both peaks actually for chlorophyll represented here. It's in the visible range. I see them both. My device, I think, is scored very well. Here, I've done what I think really needs to be done, taking a look at something with a colored solution. Barbara.
Yep, you've laid it all on the floor, JP.
I have.
Now it's time
this
for
is a tough competition. I
UV
realize.
to step
but
up here.
Are you able to compete with this level of analysis?
Well, that's some pretty nice data. I gotta see what we can see with this machine.
Okay,
So I'm gonna
yeah.
start with the
Show me.
canola
Go
oil.
ahead. Start with that canola
Just
oil.
like you did.
You do that. You just do that. All right. What do we got?
Okay.
Oh, okay.
Oh, interesting, right?
Yeah.
That is
All
a
that
very
data.
interesting spectrum. Well, I don't see anything in the visible.
That's
Of course,
right.
I didn't expect to see anything in the visible. I got this kind of like ghost shape going on over here in the UV, which I wasn't able to see with mine, but it doesn't matter because I was looking for chlorophyll, right?
That's
So,
right.
all right, Barbara, what do you got?
Okay. All right. So if I look at chlorophyll next,
In this olive oil sample.
Huh, okay.
olive oil. Okay. So let me,
Collect that
Yeah.
and, whoa, look at that.
yeah, I
That
can see
peak
it.
right there at 672, that's what we expected it.
Yep.
So
Yep.
we're seeing a very nice chlorophyll peak. In fact, I'm seeing both chlorophyll peaks there. Let me bring those two together. There it is, her canola oil, her olive oil. I'm able to see the chlorophyll in one that I wasn't able to see in the other. And so to me, it looks like a win-win. I am prepared to say that I was able to see chlorophyll. Barbara, I was impressed. You were able to see chlorophyll too. I think the score is 3-5 now.
Yeah.
Let's do an instant replay. Roger, what do you see here?
I'm excited to see that you can see both in the visible some things that are going to be exciting to see in those vegetable oils that have plant matter, like olive oil. Okay, you can see the chlorophyll that's in there. But if you really wanted to see something down in the oil region, especially about our health, we talk about that oils have double bonds or have multiple double bonds. We call that unsaturation because they're healthier for us. Then we could use our UV vis spectrometer to look at that because the more double bonds you have, that sort of widens those peaks out and moves them ever so slightly further towards the visible. As a matter of fact, we'll take a look as you see here.
Sure, so I'm looking at these. So we were doing canola oil versus olive oil. Barbara put those both in there. We saw the same peak for chlorophyll, but we do see something funny going on there in the ultraviolet. And of course, if I take a look at the chemical structures for these, what do we notice there, Roger?
You know, you've got these fatty acids that are part of oils, and if there's a double bond in there that causes the chain to bend, that allows them not to line up nicely like butter or lard that's a solid at room temperature. They're not straight, so they can't lay on top of each other. They're liquids, and that's what makes oils different from fats. But you'll notice that there are more double bonds in the canola, which is what we're excited about in terms of health, because those kinds of are easier for the body to break down, and they're considered healthier in the long run.
Yeah, we see that as an extra peak over here,
That's
don't
right.
we? So, Roger, you did a whole bunch of these. Actually, we took a whole bunch of oils and dropped them in there just to see what it would look like on Barbara's device. And every time we add a double bond, we see some additional peaks showing up here. And that, what a great opportunity.
That's
Now,
right.
I don't know if it's fair to say that she wins or loses because we still saw chlorophyll together.
That's right.
But Barbara's device is showing some other stuff.
That's right.
Oh, but everybody wins in this round.
That's
Everybody
right.
wins, but the score now 3-6.
Right.
3-6. So here we are, 3-6 in our battle spectrometer. It looks to me ultimately like I scored high. I scored points in every single one of our rounds, but Barbara scored more points in every single one of her rounds. What's going on here, Roger? What's happening in this competition? Did she cheat?
That's exactly right, JP. And you know, if you're going to look into your classroom, you want to get a spectrometer in the hands of every student, I think you want to take a look at the visible. You can get all of the kinds of experiments because we're using the same software in both of these to examine the light that's there. You'll find that this is a good way to get every single student to have a spectrometer to look and really learn from what they're examining. If you want to reach beyond the visible light range, then you can step up to the UV vis. And that is going to give you a little bit more accuracy. It'll also give you some values that land right on what we accepted values are, and we can then explore more questions about organic chemistry, things about oils, things about health and foods that you can see in the parts of the spectrum you don't see. And so in that sense, you've got some easy choices to say, which one do we need? Maybe you need both for students hands-on, and you can then do some of the more powerful analysis because of the extended range in the UV vis. But either way, you're going to be a champion by using these.
Wow, so who's the winner?
I think you are as a teacher because you have options to buy.
At home, you are definitely the winner. So, ladies and gentlemen, a great competition. Barbara, you did a great battle there.
game,
I'm
good
very
game.
pleased with the way you came out. Very good game. And I'm not a sore loser because clearly I am also a winner in this competition. And we do have a brand new device, the UV Quiz. And ladies and gentlemen, if you are an institution and you're looking actually to experience this UV Viz, all you have to do is reach out to us and we can see if we can't find a way to get you to experience experience this in your own laboratory in ways that maybe you want to take a deeper look and see if it fits your program, we can do that, can't we?
Absolutely. We can get you out a trial and a hands-on sort of a trial to explore some kits that you're seeing what we've done, whether those are oils, some Beer's Law kinds of analysis and solutions, and you can take a look at what our labs look like anytime because they're all posted on our website. If you go out to the UV-Vis spectrometer, if you look at PASCO.com, and you'll see what our labs look like, but you can also get a hands-on like he's talking about.
Excellent. All right. Well, ladies and gentlemen, thank you very much, Barbara. Thank you very much with your device. Thanks to our device and our sports commentator, Roger, for joining us today. And of course, always, ladies and gentlemen, we wish you the best of luck, great teaching, and good day.